Hello guys, today we're going to see about k-means clustering. K-means clustering is a type of clustering which is used in unsupervised machine learning. To perform k-means clustering in Python, as a first step we have to import the packages, essential packages to perform k-means clustering. As a first step I just importing NumPy, Pandas and Matplotlib for visualization, and from sklearn clusters import k-means. Since we are going to perform k-means clustering, we're just importing a k-means class here, and also I'm just importing the dataset. I'm using Instagram visits clustering.csv. In this dataset may contain 2600 rows and 3 columns. Here you can see the 3 columns are the user ID, Instagram visit score, spending rank. Since the user ID column is not useful for us in model predicting and also in model fitting, we're just dropping it using this drop function drop, and just providing the column name. This is nothing but the user ID, and I go the axis 1. The axis 1 represents the column. Suppose we have give axis 0, it actually deletes rows. And this is all about our dataset. The dataset is changed to this to this. This is contain only 2 rows. So sorry, 2 columns, and the same rows, that is 2600 rows. And we are just visualizing the two features, which is nothing but Instagram visit score and spending rank, using the matplotlib scatter plot. Now we can see, as you can see in the visualization map, there are 5 clusters. So I'm just giving 5 clusters here. Okay, from in this cell I'm just creating an object km from a class called k-means. I'm just also passing a parameter which is nothing but a constructor. I'm just providing a constructor that n clusters equal to 5. I'm providing here 5 because, as we can see in the matplotlib scatter plot, there are 5 clusters formed here. So I'm just giving a 5. This is an approximate value only. The correct value will be can be found in the latter part of the video. Now let's creating an object for called km, and we are going to fit and predict the dataset. So for that we are just telling km dot fit predict, and also providing the two parameters. So one parameter is with two columns, which is nothing but our dataset's first column. This is nothing but Instagram visit score, and also we are just passing spending rank. Okay, uh, this will predict and fit and predict our dataset, and I'm just storing it in whitebread variable. Since we are printing this whitebread variable, you can get an array like this. Actually, the sklearn scikit sklearn package itself just label and code it. Suppose if the dataset is in this cluster, it gives a label as 1, sorry 0, then 1, 2, 3, 4. Likewise, it provides an automatic column. Suppose in the first data point, you can see if his Instagram visit score is 63 and spending rank is like 24, you may get cluster as 4. This is nothing but the fourth cluster. So like that, it proceeds. Now we are just segregating the 4 clusters, which is nothing but 0 represents the first, and for first represents the second, and the second represents the third, and the third represents the fourth, and fourth represents the fifth cluster. So we're just segregating into different data frames, and we are just also visualizing it. Um, To visualize that, we are just using the scatter plot, plt.scatter function in matplotlib. For first cluster, we are just providing cl1, which is nothing but the cl1 variable, and this cl1 data frame has 2 rows, which is sorry, 2 columns, which is nothing but Instagram visit score and spending rank 0 to 100. I'm just labeling it 0 cluster 0. For the simultaneous process has been continued for up to 5 clusters. Here you can see I'm just plotted at 5 clusters, and I also plotted another one, which is nothing but the centroid. The main concept of k-means clustering is to find the perfect centroid. So I'm just using this method called km. Km is nothing but the object we have created before, like this is here. From km, km object we just we are just using the centers cluster center is nothing but it will provide the center x and y axis of the cluster centers, which is nothing but the centroids. For that we are just passing the x axis argument as, okay, selecting all rows, and the first column. And as a y-axis argument, we're just passing all rows in y-axis, and also the second column. That's all about the centroid. When we visualize it, we can get like this, the image like this, which contains three clusters, as you can see. Sorry, five clusters, which contains its own centroid at the center of its position. You can see in this cluster, we can see the one centroid. Each cluster contains one centroid at its centermost position. Uh, since this is all about the k-means cluster, but in some datasets we may also use min-max scaling technique is also used to produce good model for fit and prediction. The min-max scaling, what it does means it just produce the values between 0 and 1 within the given column. Here you can see in after pre-processing technique with min-max scaling, you can see the values are between 0 to 1, which is nothing but you can see that does not cross between one. It is more similar to the sigmoid function. Further, we are just importing from SQL under preprocessing import minmax scalar, and also we are just creating an object like km underscore sc for minmax scalar class, and we're just fitting it using the which column we want. I'm just first giving the first column, which is nothing but Instagram visit score, and also I'm just fitting it, and also using the transform function, and also save it in Instagram visit score column itself. So what it does means it does what is this transform function does means it does transforms the real values to zero values between 0 to 1. So I'm just also proceeding the same function to the second column, which is nothing but spending rank 0 to 100. And you can see after this pre-processing, all the values in the both columns are between 0 to 1. So it is very too easy to clustering. I'm just proceeding with the same technique we have just used before, like fit predict. I'm just passing two arguments, like one argument with two columns like Instagram visit score and spending rank. Here are the results. Almost two results before preprocessing and after preprocessing are similar, but in another dataset or various dataset which may differ. So it is recommended to use the min-max scalar preprocessing technique. Here you can see I'm just finding the centroids of the given clusters. Here you can find five centroids, because there is clusters, so we can find five centroids. If there is three clusters, we can find three centroids. So these are the centroids. This is the x, and this is a y value. This is nothing but five clusters of x and y coordinates. As we can see, before we are just segregating into clusters and just plotting. You can see the same output is obtained as compared to this picture, but in this data set it is comfortable, but in various data set it may be differ. So it is recommended to just perform the min-max scaling pre-processing technique.